Okay, guys, we are starting our star practice, our star review today. So today we're going to start with the notes, and I have these posted along. I have these posted in your assignment as well. If you can print it out and follow along, that's awesome. But if not, then you can just write it down and follow along with me. Okay, so today we are going over 7.4a, which is constant rates of change, and 7.4c, which is constant of proportionality. That was back at the beginning of the year. Okay, so we're going to write here rate of change. Rate of change describes how one quantity changes in relation to another quantity. Okay, so that's when we're using our equations, y equals x or anything like that. Okay, the rate of change is the slope. A proportional relationship between two quantities is where the rate of change is okay. Sorry, guys, I kind of blanked. A proportional relationship between two quantities is where the rate of change is constant. That means it's the same between each and every point. Okay? Constant rate of change is represented by the equation y equals kx, where k is going to represent the rate of change or our slope. I don't know why I put that there. Just don't worry about that. Okay? The constant of proportionality is represented by k in the equation. Okay? In the equation y equals kx, or by m in the equation y equals mx plus b. Okay, so this one right here, this equation y equals mx plus b is going to be the form you see it in most equations. Okay, so the key here is to know that m and k are the same thing. They both represent the rate of change or the slope. Slope and rate of change are the same. The constant proportionality represents the ratio between y and x and is written as k equals y divided by x. Okay. Sorry. So to find the constant proportionality, if you don't have the equation, it would just be the number that's next to the x. But if you don't have the equation, you're just going to divide the y value by the x value, and that'll give you your constant proportionality. So let's do a couple examples, and I'll show you. So this is a verbal example. That means it's a word problem. You got to read it, and it gives you all the information. Cheddar cheese costs $4.25 per pound. Which equation best represents y, the total cost of x pounds of cheddar cheese? Okay. So we want to identify the rate of change. So anytime you see one of these words, per or each or every, anything like that, that whatever number is right in front of it or attached to it is going to be your rate of change. So my rate of change here is $4.25. There is no y-intercept, so on these, my constant rates of change, there's not going to be a y-intercept. And then we're going to write the equation. So y equals, so we're going to replace the m with our rate of change. So 425x. And then there's no y-intercept. That's what the b is, so we're just going to leave that 0. So my equation here is y equals 425x. My constant proportionality, like I said, is just like our rate of change. So my constant proportionality would be 425. Okay, so this is the equation. Which equation best represents it? Y equals 425x. And my constant of proportionality is that number that's right next to the x. And that's all there is to it. Let's do another one. So now we're going to go from a graph. Okay, An artist is making a scale model of a statue. On the model, 2 inches represents 1 foot on the actual statue. Which graph best represents this relationship? So the best thing to see is that on all of these inches, the model size is on the bottom, which means I need to look for 2 inches first. Okay, so that's 2 right there. So these are all our 2s, right? Represents 1 foot on the actual statue. So the side is a foot. So 1 foot on the side. Sorry. So we want to make sure these are all going by 2s. That when I look at 2 inches and I go up to the line, that it's at 1 foot here. That's at 2 inches and 2 feet. So it's not that one. 2 inches, and that looks like it could be 1 foot. So let's keep going. 2 inches, that looks like it's too little. Okay. And then 2 inches, and ooh, that's all the way up at 12. So it's not that one. So I want to make sure 2 inches and 1 foot. So every 2 inches is an extra foot. So 4 inches would be 2 feet, and then so on. 6 inches, 3, 8, 4, and so on. So it's definitely C. Okay. So my rate of change here was 2 over 1 because it's 2 inches over 1 foot. So my rate of change was 2. I'm going to write it as 2 over 1 as my rise over run. There's no y-intercept, that's my 0. And then I'm going to count up or down for the rise. So I'm going to count up 2 and then over 1 on each graph to identify what's true. And that's what we did. Okay. One more, our tables. So this is our last form we'll see it in. Caroline's cell phone plan costs $32 per month. Which table shows the sum of the amounts that Caroline will pay for a cell phone plan over the next 4 months? Okay. Identify the rate of change written as change in y over change in x. So my change in y. So my rate of change here is $32 per month. So that's going to be 32 over 1. Okay, and then we find the change in x values on each table. 32, 32, 32, 1, 1, 1. Okay, and I just did that by 32 minus 0 is 32. What do I add to this one to get to that one? Okay, so this one does, when I do y over x, because y is always on the bottom, x is always on top, it is 32 over 1. Okay, but I'm going to tell you why it's not this one. Because every month she has to pay $32. So if I start at the first month, I'm still paying $32 on the first month. So it can't be $0 on the first month because I need to pay $32 on the first month. So it's not going to be that one. Okay, the next one, plus 8, plus 8, plus 8. And that's plus 1, plus 1, plus 1. And so that's 8 over 1. So it's not that one. Let's see, 4, 4, 4, 1, 1, 1. That's 4 over 1, so it's not that one because we're looking for 32 over 1. 32, 32, 32. 1, 1, 1. So that's 32 over 1. And the first month starts at $32 because I have to pay $32 in the first month. So it would be J. So we found our change in x, we found our change in y, we matched our rate of change, and my constant proportionality is y over x, which is the rate of change, which would be $32 here. Okay? Sorry. And that's all there is to it, guys. Today is just the notes. I do have an IXL code for you to do today. 2NB. It's for unit rates. Okay, and a unit rate, I don't know why I didn't put it on here. Oh, we're doing unit rates next week. Hold on, let me get the correct one. Okay, guys, so the correct code we're going to do is LKZ. That's for constant proportionalities from tables. Okay, so you're going to do what we did on that last one. There are going to be questions where it asks you, is it proportional? Is the table proportional? Okay, it's proportional if when I divide all the y over x's, they're all the same. Okay, so I need to divide each one. So I'll give you an example here on the one we just did. When I do 32 divided by 1, I get 32 over 1. When I do 64 divided by 2, it's still 32 over 1. It still reduces to 32, and so on. So all of these, when I divide them, 128 over 4, y over x, I get the same answer. Okay, so these would all equal 36. Okay, also, when it's proportional, our zero, if we had a zero value here, our zero value would be 0. Okay, so it's going to start at 0 at when the x value is 0. So like up here, where this says 1 over 0, that's not going to be true because 1 over 0, I can't do. I can't do 1 divided by 0. And then it would be 32 divided by 2, which is 16, 3 over 60, 64 over 3. Sorry, guys. Over 3 would be 21 point something. Okay, so these wouldn't, because this wouldn't be, because it doesn't have the same constant of proportionality between each of the y's and x values. This one would. 8 divided by 1 is 1, 16 divided by 2 is 1, 24 divided by 3 is 8. Sorry, they're all 8s. This one, 32 divided by 1 is 32, 36 divided by 2 is 18, so it wouldn't be this one. Okay, so that's all I wanted to tell you. So if it does say, ask if it's proportional, check all of the values y divided by x. Divide each y value by its matching x value, and then it'll tell you if it's proportional or not. Okay, and that's all we're doing today. If you have any questions, let me know, guys. Thanks. Bye.